In Module 4, we are looking at one of the key concepts in calculus, and that is the definition of the derivative. The derivative is a rate of change, and to help us better understand that, we can move back to our algebra. If we were given the equation of a line, y equals mx plus b, we would recall that the rate of change is m, which happens to be the slope of that line. Looking towards calculus, we know that the definition of the derivative is given by the limit as h approaches 0 of the quantity in the numerator f of x plus h minus f of x all over the variable h. Now we can combine these two concepts to better help us understand the definition of the derivative. So if we let our function f equal the equation of a line, let's say mx plus b, and then substitute this into the definition of our derivative, we would have that the limit as h approaches 0 of the quantity in the numerator mx plus mh plus b minus the quantity mx plus b all over the variable h. And as we cancel out like terms in the numerator, we are left with the limit as h approaches 0 of mh over h, which reduces and simplifies to m, which happens to be the slope of our line, our rate of change. Now the definition of the derivative does not only work for linear functions. We'll see that this rate of change can also be found for quadratic functions, cubic functions, logarithms, and the other transcendental functions we will see in this chapter. I'll look for any questions you might have in the discussion board as we learn more about the derivative.